Welcome everyone to lesson 3.2.3. Today we are going to be practicing solving equations. How can I use my equation solving skills? And please remember, as I teach mathematics, I am giving you tools for your toolbox. And you have to know how to use these tools to solve all these problems, okay? And so if you guys are practicing these skills, you're going to be better off solving these equations. And in real life, later on down the road, some of you might feel like, I'm not going to use this, Mr. McCoy. I'm trying to give you a way of thinking, problem solving skills. And that's what this is really about. So, solving equations to solve problems. Here we go. Problem 3-89 in your math notebook, upper left-hand corner. In lesson 313, you investigated the big C tile patterns shown below. Remember, we had figure 1 and it had 9 tiles. Figure 2 had 15 tiles. Now, can you have figure 1.5? No. Remember, this is a discrete graph or discrete problem. There are no halvesies. The rule you found for this pattern was y equals 6x plus 3, where x represented the figure number, x, and y was the number of tiles. Okay, x and y. Penelope wants to know how many tiles will be in figure 50. How many tiles, that's y, will be in figure 50? So remember, when we read language arts, we need to be able to translate that into math. How can you determine this? Write out in words what you would need to do with your rule to answer her question. So here we go. We take our rule, y equals 6x plus 3, and we want to know when x is 50. That's her question. How many y's when x is 50? So here we go. We're going to take y equals 6, but it's not x. It's the value of x, 50, plus 3. And we go ahead and solve this. All right? We say 6 times 50 is 300. 300 plus 3 is 303. 303 what? We know that x is the figure, y is the tiles. Does this sound reasonable? Does it sound reasonable that figure 50 has 303 tiles? Yeah, I think that sounds reasonable. I mean, look, figure 3 has, I don't know, how many tiles is that? Like 21? It's going to build. It's going to grow. That sounds completely reasonable. Okay, going to the right. Lou wants to reverse the process. We're going backwards. He says he has a big C figure made up of 45 tiles. That's y equals 45. And he wants to know which figure number. That's question mark x. We need to find x. In the rule, y equals 6x plus 3, which variable must equal 45? Well, it says it right here. Tiles, 45 tiles, that's a y. So when we solve, this is off to the right-hand side, 3-90, you need to write y equals 6x plus 3. See, it's the same rule, right? When y is 45. So we're solving this problem going backwards, and we plug this value for y. 45 equals 6x plus 3. Now, we have been using tiles, and we've been using our equation mats, and we've been using our online tiles. And the question is, how can I solve this now? Well, there are 5 legal moves. Zero pair. Do I see a minus sign? No. A bottom to top flip. Do I see a minus parentheses that I need to flip? No. Step number 3, a balance. Matching tiles on matching regions. Notice that you have 3 tiles that you can take away from the right, and you have 3 tiles that you can take away from the left. You need to begin to see how to apply what we learned with maths on regular equations, okay? And we go through the math, and we say 45 minus 3 is 42 equals 6x. Legal move number 4 was a side-side flip. Notice that this could also be a side-side flip. Because if you take a positive 3 and you flip it to the other side, it becomes negative 3. Balance and side-side flip are very similar and can be used in similar ways. But our last legal move is a regroup. And I divide both sides by 6 to get x equals 7. Well, if these are tiles, 7 is the figure number. Does that make sense? Does it sound reasonable that figure 7 has 45 tiles? I think so. I think that when you look at the table, I think that that makes sense. You always want to stop and think, does this make sense? Problem 91. Norm says he has a Big C pattern made up of 84 tiles. Remember, tiles is a Y thing. Which figure number? Question mark X. When you read language arts, you need to translate that into math. So here we go. Y equals 6x plus 3. Okay? We're using the same rule because it's the same Big C problem. We take this 84 in for y. 84 equals 6x plus 3. Now, before I showed you a balance, I'm going to do a side-side flip on this one, just to show you both. A positive on the right flipped to the other side becomes a minus. There are some students that never use a balance. They always use a side-side flip because balance only works if the tiles are matching. But a side-side flip always works. It doesn't matter if they match. You can always just flip it to the other side. So a side-side flip would give us 81 equals 6x. Now these numbers have gotten a little bit big for me, so I'm going to go ahead and pull up my calculator. And I'm going to do 81 divided by 6 equals 13.5. X equals 13.5. What are we talking about in this problem? 84 tiles and 13.5 figure number? Does that make sense? Does it make sense to have 13.5 figure number? I thought this was a discrete problem. A discrete problem has no numbers in between the numbers, right? It's those whole numbers only. 13.5. Where do we see this in real life? Home Depot. Let's say you only need half a bag of concrete. Can you go to Home Depot and only buy half a bag of concrete? No, you got to buy a whole bag. Or you only need a 5-foot board. Can you just buy a 5-foot board? Nope. They come in 8-foot or 10-foot or 12-foot. They don't come in 5s. See, you need to realize that sometimes you can only buy a whole. Yes, there are some situations like at the grocery store, there's those bulk bins and you can buy by the pound. There are problems that are like this. But in this problem, it is discrete. Therefore, our solution does not make sense. You need to write, this solution does not make sense. Why or why not? It's a discrete problem. It's a discrete problem. And we need to always be thinking about how this goes. Okay. Here's what we are going to do for the remainder of this lesson. There are 4 problems. They do not match the book. What you need to do is you need to write down the left, here's the divider, and the right. And then there's another divider, and explain. Okay, you're going to go through this. I'm going to do A. You're going to do B, C, and D. But pause the video now to write down all 4 problems. Pause now. Okay, you should have all 4 problems written down. Okay, and what we're going to do is we are going to solve these 4 problems. But I am going to give you some help with our first problem. Some people have forgotten what I expect of you as we solve these equations. You do not have a mat. Could you use a mat? Sure, but I want you to get away from that. In problem letter A, you are starting off by the problem and you wrote original. And you look, 5 legal moves. What is your first legal move? Is there a 0 pair? I see 5x and negative 2x. That's a 0 pair. They're on the same side of the equation. Because they're on the same side of the equation, 5 minus 2 is 3x. The 4 did not change. The x plus 10 did not change. That was a 0 pair. Okay, that was my first legal move. Is there a bottom to top flip? Is there a negative parentheses? No. So my third legal move is a balance. Let's look for a balance. Well, I'm looking for matching tiles in matching regions. I notice I have an x in both regions. So I say I can take an x away from both sides. That would give me 2x plus 4 equals 10. Now, that's not the only thing that would balance in this problem. I also notice, Mr. McCoy, that I can balance the number 4. Subtract 4 tiles from each side. 4 take away 4 is also 0. 10 take away 4 is 6. So 2x equals 6. That was also a balance. Some people did that in the same step. Some people use that in 2 steps. If you wanted to do that problem differently, and instead of a balance, you could say, I'm going to do a side-side flip. I'm going to flip this over here. The positive 4 becomes negative 4. And notice you are left in the exact same spot. My last legal move is called a regroup. Regroup is like division. I'm going to divide both sides by 2, and I'm going to get x equals 3. Okay? This is going through our math and deciding what's the answer here. Okay? Now you may have noticed in this problem that I had the check written on the board. To check your answer, 5 times plus 4 minus 2 times equals x plus 10. Students ask me, Mr. McCoy, is this right? And this is how we verify if we are right. See, if I think x is 3, I can take that value and plug it in. 3 for x, see, right there. Right there. Right there. Whoops. Now I'm going to verify. Here we go. 5 times 3 is 15. The plus 4 doesn't change. Minus 2 times 3. You've got to follow order of operations. Multiply happens before subtraction. Minus 6 equals 3 plus 10 is 13. Well, let's do the math. 15 plus 4 is 19. Take away 6. Does that equal 13? Yes, it does. This is checking your work. If you did this exact same problem, but if you had a different value for x, let's say you had 2, and you plug in 2. 10 plus 4 minus 4 equals 12. Does 14 take away 4 equal 12? Nope, I got it wrong. And that's when you would say, oh, I need to go back and check my work because this number is wrong. I need to find the right answer. So these are the steps that I want you to go through today. I want you to go through your legal moves, and I want you to solve these 4 problems. Tell me the value of x. If you encounter a problem where this number does not equal this number, that means false, no solution. Be careful of that. Thanks for coming today for lesson 323 on how can I use my equation solving skills. We'll see you again tomorrow.